Okay, so welcome back to another video. So we have a little geometry problem here, and that's we have a square with side length 1, and inscribed there is we have another square with a side length of 2r, and then two circles with equal radius we just call this r. So what we want to find is what is the value of r is equal to. So just like any typical standard geometry problem, when you're solving for an unknown value or angle degree, depending on whatever the question asks for in some geometry problem, it's usually relying on the method of adding additional construction to, the diagram given. So this is actually going to be a little bit of a easier problem because for one thing we're going to do first is, rather the first step is that we actually want to draw a line that is like connected from the endpoints from here to here as to represent like a hypotenuse. Then with that we can there's a bunch of observations we can make, and also a bunch of other line segments we can add, and then we can also put in some implementation of formulas we can use that's going to be extremely helpful in order to find what the radius or what r is equal to. So with that, let's actually just jump right in. So as first, we noticed that, again, there's also, well, not again, but also noted is that with this entire square, there's a 90-degree angle over here, which makes sense for a square for one. So what I'm first going to do, and another thing is that, of course, this diagram is not drawn to scale. I am no artist, so apologize if it actually looks a little off, but what's important to understand is how the construction works and what some key information we can take away from this. So first, let's actually draw this diagonal line connecting from the first endpoint to the other. So it's going to connect from the midpoints. So the line is connecting through the edge. I know it's not, but that's what it's supposed to do, but also connect through the midpoint of these two circles over here. It's also nice and interesting to say that we can also see that this is a 45-degree angle over here. And what else we can do here is, because with the length of r, that means this is going to equal r as well. So I'm going to draw r over here. And then what's next I'm going to do here is that I'm actually going to draw a line segment connecting down below to the edge, to the side length from over here. So line segment going down straight down here. And another thing I'm going to do is I'm actually going to draw another line segment over here connecting from this the tangents between the endpoint, the corner, and the circle as well. So this also means that what I can say is that there's an unknown value x, we'll call this x, that we want to figure out as well. So with this is x, and it's also interesting to see that the diameter of this circle here it's r, so that means this is actually going to equal, put it like this, that's better. I'll put this as 2r as well. Hence, interestingly, it's the same length of the side of one of the sides of the squares over here. Based on similar triangles over here, we know that this is a 45-degree angle over here, so that has to imply that this is also a 45-degree angle over here as well. So what we can do here is we'll notice that if I say that we want to find something for the value of, specifically we're going to write this as find what cosine of 45 degrees is going to equal to. Well, we know that cosine is supposed to equal to the adjacent over the hypotenuse. In other words, when we're looking at it this way, we have that the adjacent is going to be x. So we're actually creating this little relationship we have in respect to this cosine of 45-degree angle. This also means that we have that find the hypotenuse, which we said that this is 2r, and then add this with r over here. So that's actually going to be 3r. So with this, now we know that cosine 45 degrees is going to equal x, and then divided by 3r. And we know what the value of cosine 45 degrees is. It's actually going to equal the square root of 2 divided by 2. And so this is left to say that this is equal to x divided by 3r. And then if we solve for x by its own, we have that 3r times the square root of 2 is divided by 2 is equal to x. Okay, so that's nice. We at least know what the value of x is in terms of r, but the whole thing is that we want to find what the value of r is equal to. So now let's actually take a look at something else that's another key important thing that's actually going to help us find what we need to find. Of course, it wouldn't be interesting to say that if we have a side value of 1, then it just sounds like what was the point of that? But it's important here. We see that specifically take the sums of these side lengths. So we just say that r is this length, so that's going to be r over here. And then we know that the length from this side leg over here is going to be 2r, but it also notes that we said that we found what x is equal to. So, well, for one, we have the 2r over here, then x, then plus r. That actually take the sum up, and then it actually gives us a value of the side length, one of the big square. So that means we have that 3r plus x is equal to 1. And so what's nice is that we can actually we already found what x is equal to, so we can just plug back for x. So that means 3r, and then add this with 3r times the square root of 2 divided by 2 is equal to 1. What I can do is I can factor out an r, so r then 3 plus 3 times square root of 2 divided by 2 equals 1. Then that means that I can actually just divide this quantity to both sides. And so we have that r is equal to 1 divided by 3 plus 3 square root of 2, and then divided by 2. Then we can actually just fix this rationalization up a little bit. Since we have a fraction under a denominator, I'll just multiply the 2 to both sides. And so we have, both, when I meant to say numerator and denominator, so at least that gets rid of the fraction over here. So that means we have 2, then divided by 6, add this with 3 times the square root of 2. I can actually factor this out a little bit, and it also helps that we don't want the radical under the denominator as well. So this will be 3 times 2, and then add this with the square root of 2. Then we can actually just multiply the conjugate. So I have 2, that's supposed to be a minus, since it's, again, multiplying conjugates, minus the square root of 2, then 2 minus the square root of 2. Then we see that we have 2 times 2 minus the square root of 2. And if I do the multiplication, this is actually just basically differences of squares. So 2 times 2 is 4, then positive square root of 2 times negative square root of 2, that's just 2, so subtract that. So 4 minus 2, that's going to give us 2. So that means I have 3 times 2. 2's will cancel. And so we have that r is going to equal to 2 minus the square root of 2 divided by 3. And that's actually the length of our radius, as we wanted to calculate this entire time. So just like that, a simple geometry problem that requires some construction, but very basic knowledge on solving these things. So yeah, that's pretty cool if you ask me.